Techniques for modeling real-life problem. The outline. What is mathematical modeling? What objectives can modeling achieve? Classification of models, stages of modeling, building models, that is getting started, systems analysis, making some assumptions, the issue of flow diagrams, choosing the correct mathematical equations, equations from literature, that is the background, what are the missing links, what are the analogues from physics, biology, chemistry, economics, geography, geology, etc. Data exploration, solving equations, the mathematical equation. It could be, if it is something that is linear, then we can approach it from analytical. If it is nonlinear equations, then we solve via numerical method. Studying the models. Do we dimensionalize? What are the asymptotic behavior? The sensitivity analysis, the modeling model output, then testing the models, testing the assumptions, the model structure, prediction of previously unused data, reasons for prediction errors, estimating model parameters, comparing the two models for the same system, using the models, prediction with estimates of precision, decision support, then discussion of the results, description of the model, deciding when to model and when to stop. Now, what am I saying here in a nutshell from the beginning here? One needs to understand what is mathematical modeling and what is it that you want to model. What are the objectives that your model is going to achieve? Because we have classification of models and we have various stages of modeling. So the first thing here, what is mathematical modeling? Models describe our beliefs about how the world functions. In mathematical modeling, we translate those beliefs into the language of mathematics, and this has many advantages, such as, one, mathematics is a very precise language. This helps us to formulate ideas and identifying underlying assumptions. Two, mathematics is a concise language with well-defined rules for manipulations. Three, all the results that mathematicians have proved over 100 of years ago are at our disposal. Four, computers can be used to perform numerical calculations. There is a large element of compromise in mathematical modeling. The majority of interacting systems in the real world are far too complicated to model in their entirety. Hence, the first level of compromise is to identify the most important parts of the system. These will be included in the model. The rest will be excluded. The second level of compromise concerns the amount of mathematical manipulation, which is worthwhile. Although mathematics has the potential to prove general results, these results depend critically on the form of equations used. Small changes in the structure of equation may require enormous changes in mathematical methods. Using computers to handle the model equation may never lead to elegant results, but it is much more robust case alterations. What objectives can modeling achieve? Mathematical modeling can be used for a number of different reasons. How well any particular object is achieved depends on both the state of knowledge about a system and how well the modeling is done. and examples are abound that will be given as we go along. Developing scientific understanding through quantitative expression of current knowledge of a system, as well as displaying what we know. This may also show up what we do not know. Takes the effect of the changes in a system. Aid decision making, including tactical decisions by managers, strategic decisions by planners. Models could be classified. When you talk about classification of models, when studying models, it is helpful to identify broad categories of models. Classification of individual models into these categories tells us immediately some of the essentials of the structure of their structure. One division between models based on the type of outcome they predict. Deterministic models ignore random variation, and so always predict the same outcome from a given starting point. On the other hand, models may be more statistical in nature, and so may predict the distribution of possible outcomes. Such models are said to be stochastic. A second method of distinguishing between types of models is to consider the level of understanding on which model is based. The simplest explanation is to consider the hierarchy of organizational structure within the system being modeled. For example, for animals, what such hierarchy will be to look at the thing from here. Is it high, low, average, individual, organs, cells, molecules, etc. A model which uses a large amount of theoretical information generally describes what happens at one level in the hierarchy by considering processes at lower levels. These are called mechanistic models because they take account of mechanisms through which changes occur. In empirical models, no account is taken of the mechanism by which changes to the system occur. Instead, it is merely noted that they do occur, and the model tries to account quantitatively for changes associated with different conditions. Two divisions above, namely deterministic, stochastic, and mechanistic, empirical, represent extremes of a range of model types. In between lie a whole spectrum of model types. Also, the two methods of classification are complementary. For example, a deterministic model may either mechanistic or empirical but not stochastic. An example of the four broad categories of the models implied by the above method classification are as follows. Let us have a look. Deterministic. The empirical there, predicting cattle growth from a regression relationship which with fuel intake. Then mechanistic, planetary motion based on Newtonian mechanism, which is nothing but differential equation. Stochastic, analysis of variance of variety yields over sites and years. Mechanistic, genetics of small population based on Mendelism law of inheritance, which is probabilistic equation. So what are we trying to say here? A pictorial representation of potential routes through the stages of modeling will be building, is B-U-I-L-D-I-N-G, building. if you are building an equation, building, then studying, testing, and then using the model. This process of repeated iteration is typical of modeling projects. That is, we build a model vis-a-vis what is the flow diagram, because from the flow diagram, one will be able to see the missing link between the previous literature and the current thing. Then studying past literature and see. Then you test your model vis-a-vis, is it going to, the existence and uniqueness law, is it follow theorem? If it follows, what happens to the positivity? Because you are dealing with human being or counting of particular thing, it could be human being or animal. Then, with your assumption, are you talking about a closed population or you are talking about an open population? Then you validate. So this process of repeated action is typical of modeling projects. And it's one of the most useful aspects of modeling in terms of improving our understanding about how the system works. We shall use the division of modeling activities to provide a structure for this rest of my talk here. So let me now pause here. What informed the model that one is interested in? Nigeria, for example, I'm happy that you can see this, our association is able to use what we call a modeling approach. We are already in what we call COVID-19 pandemic. And then to improvise, one, we need to save lives of participants and also the organizers. And you can see, what was it that we key into? We said, okay, Professor Lalero and maybe one other person, go to the center, meet with the DJ and other people, and other participants, let us just have this meeting. That's another way. So in modeling, if we look at it now, and I want to tell you whether we like it or not, we must incorporate this into our system, especially Nigeria education system. Because one can never predict any other thing of this nature. And the second thing that we need to take note is that the second stage of COVID-19, I'm sorry, because I'm also working in this very area, is that the second one is much more terrible than the first one. Yes, we are lucky that in this part of Africa that we are now, we are blessed with the sun. But that notwithstanding, more than 90% of people are not following the rules and regulation expected of what we call this COVID-19 preventive. It's always good to lay emphasis more on preventive medicine than curative medicine. I will pause here. As we go along the slide, I'll be expatiating. There are so many other areas. I'm happy we have about 172 registered participants, but to my surprise, we are less than 60 right now. What am I trying to say here? Even with this 60, it's also good, but we need to spread our information, especially the young shall grow. That we have so many areas yet unexplored. I'm happy with our father, Professor Charles Chudime. He has done all he could, and he's still trying. Professor Nomaya has tried. By this same time next year, you'll be bowing away. You'll be 70. And by federal government rules and regulations, once you're a professor and you are 70 years of age, you step aside. Even if you are not tired, you have to retire. What am I saying is, those of us that are professors, let us leave a legacy. Let us mentor those we can mentor. I want to discuss some areas that we need to get some other people, vis-a-vis whether we need to, those of us that are HOD, deans, directors of various universities or units in the universities. Professor Charles Chidume mentioned that we have about 170 something, about 172 to 76, both federal, state, private universities. Oh yes, but what we are saying is, let me pick an example of functional analysis, because our father did that is his area, Professor Chidume. What am I trying to say here? every one of us cannot move to his area of his research, because leaving some other parts of functional analysis. The same thing with our father there, Professor Peter Onomaye. He has tried in numerical analysis in Nigeria. But then we need to start pushing some of our new young lecturers to go outside to now pick some other areas of numerical, functional, even modeling, complex analysis, algebra, real analysis. Because until we do that, so I want to just expatiate by now, focusing on the area that I think anybody that still want to work in this modeling area, they can be able to work on, and then they can, in fact, it will be a kind of what we call in-depth research. Air pollution. I don't think there is any major city, whether urban, rural, village, or whatever we may like to call it, without having this issue of air pollution. What is the overview there? Local pollution, e.g. in urban, smoke, toxic releases, acid rain, global issues, and related chemicals. Typical aspects that need to be addressed by anybody that wants to model. You need to talk about the concentrations of those chemicals, the health impacts, the trends, impact and cost-benefit analysis of proposed control measures. What am I saying here? Now we are about to enter Harmattan here in Ilorin. I don't know that of Lagos, and I cannot speak on behalf of those of you staying in Abuja. But now during the Harmattan, what you see that we face, those people that are asthmatic, how do we address? Because once they just have what they call release of air pollutants, they react. And what will be the impact on their health? What will be the trend? How do we talk about the cost-benefit analysis of the proposed control measures? Water pollution is almost everywhere also. Sewage, agricultural runoff, pesticide residues, acid rain, chemical discharges. Relatively few people in the world have access to clean water. Clean and something that the people can. In fact, I really sympathize with people in Ogoni land there now. You see that with the sea pollution there. Any borehole they try to think, before you know what will happen, they will discover that it's the oil they are just taking in, and we know the health implication. So the transport, for the typical aspect addressed by the modeling, you talk about the transport and environmental fate of the pollutants. So you look at the thing there, transport, then you look at the effectiveness of remedial measures. Groundwater modeling. Groundwater modeling, when you talk about this issue of groundwater modeling, sorry, please. If we look at this groundwater thing, availability of groundwater and the investigation or remediation of contamination patterns. Yes, so many people, especially the geologists, the geophysicists, and what have you, this is their area. How safe yields from the wells? The direction and the rate of the movements, the spread of the contaminants, evaluation of remedial measures. Anybody that wants to work, these are the open area that people can still talk about. Yes, there's even water pollution, groundwater, and water supply. There are many notable instances where surface of groundwater is being used at a non-sustainable rate. An overview. That is the issue there. So anybody that wants to work in the modeling there, you have to talk about determining the capacity of supplies, the effectiveness of the policy, and incentive programs. Just of recent, I heard that some state governor want to start giving people some levy tax in form of tax that anytime you want to have what they call a sink in your, or you want to try to have a borehole in your house, they have to levy you. And I keep on wondering why. But then, the concept of global warming, the overview there is the greenhouse gases, such as carbon dioxide, cause more of sun's energy to be retained by the earth, leading to a rise in average temperature. Typical aspects addressed by modeling here: interactive effects of the greenhouse gases, sunlight direct reflection by the aerosols, and increased cloud cover, changes in vegetation, economic impacts, e.g. on agriculture. Sea level changes. Melting of polar ice due to increase in global temperature could redefine coastlines, displace populations, and affect ocean currents and climates. I'm happy that in National Market Center, there is what we call mutual agreement and mutual understanding and an MOU between NIMET and National Market Center in this area. Feedback on the loops. So, feedback loops. Large ocean may lead to a higher amount of evaporation, more water in cloud state, perhaps more reflection of solar energy. Yes, this I need to equally expatiate. Federal government, as far back as in the 80s, established 4 centers, 2 on nuclear energy and 2 on solar energy. IFE and Ahmadu Bello University, they have nuclear centers there, the 2 centers. On solar renewable energy, we have Usman Dan Fodio University, Sokoto, and we have University of Nigeria, Nsukka. Forest destruction. Inject more greenhouse gases into atmosphere, reduces world photosynthesis capacity, which removes carbon dioxide and also leads to erosion, slitting of waterways and species. Then for somebody that want to model, you need to look at the role of forest as carbon reservoirs in the world climate models, impact on deforestation of trade policies or economic incentives. Most of us have been talking Nigeria now with NEPA not being, or power holding, they call them now, not being all that, the issue of power generation in Nigeria is zero. Most people have not been diversifying to what we call renewable energies. Yes, it's good, solar and the wind. But then one has to take into consideration the cost to set up a solar, let us say 5 kVA. You need to take into consideration some things. What are those things? How many number of panels you need to be able to power the 5 kVA inverter? What are the things that you want to use? You want to power your fridge, freezers, your gas cooker, your electric stove, your washing machine, your LCD screen. You want to have the AC. Then if you want to have the AC, there is no way you can use less than 6 to 10 batteries. Also, when we talk about some batteries too, we need to take into consideration. Yeah, the deep cycle batteries, yes, some are not expensive, some are very, very expensive. But then the life cycle is the most important thing. Why am I gambling to some of these areas is that I've collaborated with Solar Energy Center in Sokoto. So if we look at assuming during this Harmattan, you want to save costs, we have what we call solar heating, solar heater. And then before you know it, once you are able to have a good battery, it will be able to reserve, and then you'll be able to power your thing, and then have hot bath in the morning, and later in the evening. But in modeling, we need all these things. We have some variables and parameters that one need to take into consideration. If I want to power using solar or wind energy, if I'm using maybe 220 amps, how many hours am I going to enjoy the solar electricity? 4 or 5 hours? If I'm using this luminous tubular battery, that is the one that you can always add water, 5, 6 years, that's the end. If I'm using lead battery, yes, that can last between 8 to 12 years. If I'm using lithium battery, that can last me 20 years. But then the cost, an average of luminous battery, for example, now 220 tubular, is in the neighborhood of 125,000 per one, per just one. You can imagine. So 12 volts. So what am I trying to say here? You look at, if I want to enjoy, I want my family to enjoy 10 hours, then I need to increase the number of battery. For the lead battery, that is in the neighborhood of 250 to 300 per single cell. If you are talking about this lithium battery that can last 15 to 20 years, you must be ready to part with 500 to 550 per one. And assuming you need 4, look at it. But most of these things, once you set up everything, if you compute the number of money that you are using, spending, empowering, whether your diesel or petrol engine per day, multiplied by per week, per month, per years, at last long run, is still cheaper to set up this solar or renewable thing. It could be wind power, electricity. So, forest destruction. What are the overview there? Inject more greenhouse gases into atmosphere, and then this will reduces the world photosynthetic capacity, which removes the carbon dioxide and also leads to erosion. Then the restricting of the waterways and species loss. What am I trying to say here is this, and I'm happy I want to make reference to Benue State, where the DG and the Chief Executive of National Macro Center happen to come from. I remember I supervised David from Federal University of Wukari, and I asked him, since you are from Benue, that is the food basket of the country, the people have been using chemical to attack the pests using vis-a-vis herbicides, pesticides. But what I'm now saying is, in the whole world now, globally, people have been saying, no, stop using chemical to attack pests. Instead, use what they call biological model. What is it? What am I trying to say here is the concept of pre-predator. For example, in a small house, if I know that I do have rats that do worry me and my family, all I need to do is just to introduce one simple cat, one small cat into the house. Even just the sound of the cat will scare the rats. So what am I saying here is this: pre-predator model, biological control all over the world is far better. And also, if you look at it in the long run, one is not all that harmful. I've been seeing people selling all this otapia, selling all this chemical. If you use this, it will be able to take. But how about the side effects? Assuming one still have some kids, children of maybe less than 5 years old, and they happen to just have their bread. The bread is just kept somewhere, and the rat happen to just feed on it, and the chemical is already with the cat. With the rat. What will happen? So these are some of the way we talk about the biological control. Next, ozone depletion. Certain chemicals, depletion ozone in the stratosphere, such ozone shed the surface from ultraviolet light, which can harm humans and plants. In modeling, you look at both the short and the long-term ozone predictions, quantifying physical and economic impact on the health and agriculture, hazardous materials. Yes, the overview of the hazardous materials include dangers to the public and environment from both planned and unplanned releases of the hazardous material. Anybody that wants to talk about modeling, then you can look at the concentration, the transport through the environment, the population exposure, health effects, the probability and the effect of the accident. Next, solid waste. The concept of this solid waste thing, there is a popular saying that from waste to wealth. Currently, one of my postgraduate students who work on the solid waste management, vis-a-vis how can we convert some of the solid waste into what we call biogas. The biogas that will in turn give us what we call electricity. One, it can be useful instead of using this what we call it, the normal gas that is so expensive. You can convert this solid waste into your biogas. The biogas can later on be converted into electricity. Malaysia, Singapore, and all the other advanced countries, they've been using that type of model. Hazardous waste. The overview there. Hazardous waste are now variously incinerated, buried, reprocessed, or otherwise treated for disposal or reuse. I know of a graduate, as far back as for the past 20 years now, year 2000, in Abuja. His major work has been how to get as many waste collection centers as possible. And he's a multimillionaire now. Most of us believe in the so-called white collar job. You can always think, use the knowledge of mathematics and be creative. Okay, if I know that I live in Gwagwalada and I discover that the way people dispose their things have not been ordered properly, get some, what we call the manager, get some refuse collection center somewhere, keep it there for them, and be charging them, even if it's just 500 per month or 1,000. Imagine having about 100 to 200 households, or houses rather, where they have to be paying this type of 1,000 naira and what have you. So now, if we look at the next thing that regularly or incentive program, yes. Next, ocean pollution. Years of routine dumping of waste material at sea by many nations make it difficult to control this practice, despite some treaties enter into. What am I trying to say? Anybody that want to work, this is what we call environmental modeling. Environmental fate of the materials disposed of at sea. These are the things that anybody that want to model need to look into, both in the physical environment and in the food chain. Because we need to go to our elementary biology. When you talk about food chain, if I have a grass, I have insects, I have a grass cutter. From grass cutter, I have a lizard. Lizard, I have another thing that it could be snake. Snake in that order. So that is the thing that I'm trying to say here. Then we have what we call environmental impact analysis. Overview. Evaluation of the total environmental impact of major development projects or industrial facilities. Anybody that want to model in this area need to look at what they call the air, water, the noise, the traffic, the thermal, ecological, and other issues, and then build in the cost-benefit analysis of the alternatives. Now I'm coming to population dynamics now. Population dynamics, when we talk about population dynamics, and that's why I'm happy with this issue of this society, that in fact is just what we call a kind of collaborative research between the staff of Mathematics Department of Unilag, and those of computer. So what I'm saying is other universities should try to equally have such thing. I do have similar here. Anytime I'm supervising a student, if it has to do with what they call a botany thing, or let me start from the plants, then I need to pick a professor of plant biology that will be a co-supervisor to that candidate. If I'm talking about something that has to do with zoology, I pick a professor of zoo animal biology to be part of the supervisory team so that students will be able to gain, and also the supervisor also will gain because it's a two-way phase. Now, in population dynamics, overview, ecological effects on plant and animal population of natural changes or perturbation by human action. Overfishing, predator control, dams, and what have you. A modeler or will be person that wants to work on PhD, we need to look at retrospective or advanced evaluation of projects or government policies by the model simulation. Let me shed more light here. There was this person, this thing happens almost about 15 years in a university. I don't want to mention the university. The person in charge of giving special animal feed to crocodile and some other animals under their zoological garden. Then, because like I said, over 15 years, he's a junior staff. His salary is less than 50,000. But then they earmark over 50,000 for feeding of those various animals. And I now asked the chap one day, I said, look, what is happening? I learned that one of the crocodiles just died. He said, yes. He said, please, I should just, Prof, don't mind these people. I've not been able to feed my family very well, and they want me to feed the animals. I don't know whether we're getting the gist here. So what I'm saying is until we are able to do proper education enlightenment to the people that are keeping the so-called zoo people there in the zoological garden, or it could be maybe, so that they'll be able to know the importance of insects, plants, and other animals to human beings. Environmental health impacts. Determining whether there is a connection between observed diseases and some environmental cause or contributor. It's just like a nurse, a doctor, and other people that work in our teaching hospitals. The risk involved is not something that we can be able to just pick. In fact, you cannot monetize. Now, anybody that wants to model, have to talk about exposure modeling here and statistical evaluation of suspected disease anomalies. Next, biodiversity. Preservation of diverse species and gene pools for reason ranging from just beautification to ecology to development of medicine and other products. We are blessed in Nigeria. I remember when Professor Frank Sotte, when I brought him down to Nigeria here, from National Medical Center down to University of Lagos, Ibadan to University of Ilorin, down to Usmanafo de Sokoto. What he saw was this issue of grain thing. And I keep on wondering. He said, Demo, you in Nigeria, you are blessed. Which is true. No doubt about that. Most of the plants we are yet to be able to know the medicinal and usefulness of some. And it only happened Professor Chris Morty, a professor of biotechnology from India. We entered an agreement with this university in India there. We brought him down to Ilorin here. And then, while I was the director Center for International Education, and then he showed us so many things that, in fact, University of Ilorin, our teak production, our so many other things, how each and every one of our plants can be converted into a medicine, and that will be useful for human consumption. So it's not only for beautification alone. And I was so much surprised. And the VC then was saying, okay, this is good thing. Said in India, that's what they do, which is true. Most of the Asian countries now, India, Japan, China, Thailand, Malaysia, Singapore, etc., they don't joke with what we call food supplements. Okay? Now, wetlands. Wetlands are important for many reasons. Habitat flood, erosion control, groundwater recharge, typical aspect of address by modeling, quantitative evaluation of value, either for advanced decision or setting charges for past damages. Impact of the world, human overpopulation combined with poor conservation practices has led to the growth of desert in areas that were previously covered by vegetation. Typical aspects that can be addressed by modeling: interactive effects. Interactive effects of human activities and climatic episodes.
Prof, sorry, I think you have exceeded the 30 minutes, sir. You may want to round up to give time to questions.
Okay. Let me just, so since I'm going to, now, I'm happy, and we must equally welcome the Dean of Faculty of Information and Communication, Professor Rashid Jim. Is a professor of computer, and some of the things I want to talk is, what are those things that may soon be the reality of our world? Auto repair shops will soon disappear. Petrol diesel engine it's going to be replaced with electric motor. 40 electric motors are not going to be repaired in dealership, but they will be sent to this thing. Then petrol pumps will soon go away. So what I'm saying is, street corners, we have meters that dispense electricity. Smart, a baby of today, we only see personal car in museum. The future is approaching faster than most of us can handle. Kodak in some 20-something years ago sold about 85% of their photo paper worldwide within just few years. But what we are saying is, with the Android phone now, most of the thing, in fact, it's just a thing of the past. So what I'm saying is, with the science, technology, mathematics, and what have you, the future will be good. Now, what are the things? I work in modeling, especially like I said in COVID. Avoid touching men to stop. That is my message. To stop the spread of COVID. M their mouth, E their eye, and then nose with unclean hands. Wash your hands with soap and water regularly. Fulfill the rights of women to prevent COVID. W there for women, the first one, wash your hands. O, obey directives and move away from crowded places. E, exercise regularly but indoors. No shaking, no hugging. Now, there is a quotation. It's not by me. Someone once asked a teacher, why do you feel proud of being a teacher? And the teacher smiled. He smiled and said, a lawyer's income increases with increase in crime and litigation. Take note. A doctor's income increases with increase in disease and illness. But a teacher's income increases with increase in knowledge, prosperity of people and nation. Thank you. God bless you all. These are some of the textbooks: mathematical modeling, essential biology, modeling features, and what have you. I remember some people asked me a question that I should please give them some list of recommended textbooks for a beginner. And these are 3 good textbooks for a beginner. Thank you all for listening. Thank you.